This lesson is an introduction to the 6 trigonometric functions and also talking about cofunctions. Now, here's the deal. This is called right triangle trigonometry, and we can totally do this because right triangle trigonometry and the definitions in this involve ratios of sides of a right triangle. Okie doke? So here we go. Let's just look at some of these ratios. The sine of the angle theta is equal to the ratio of the side opposite theta to the hypotenuse of the right triangle. Just a reminder that the hypotenuse is the longest side of the right triangle and it's always opposite the right angle. Opposite means it's a leg of the right triangle, and a leg of a right triangle is always one of the two sides that form the right angle, okay? And opposite means I have to drive my car over to the other side here, and it takes a long time to get there. Adjacent is just next door. So the sine of this angle is the ratio of the side opposite to the hypotenuse. The cosine is the adjacent side over the hypotenuse, that ratio. The tangent is opposite side over adjacent side. Now, sine and cosecant are just, their ratios are just the reciprocals. Okie dokie artichoke. And the same way with cosine and secant. Their ratios are just reciprocals. And tangent and cotangent, those ratios are just reciprocals. Now you can remember these guys by this SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Using the first letter of each of those words, you get SOHCAHTOA. Now back in the day, they used to do some old horse caught another horse taking oats away. I like that too. And then there's some other ones that, you don't say because they're not that nice. All right, let's do wanna. Yeah, let's. Now, also, just to give you an idea, and I just told you about this, but just to kind of reinforce it, the sine and the cosecant are called reciprocal functions because their ratios are flipped. Okay? And the same holds true for cosine and secant and tangent and cotangent. They're called reciprocal functions. And then we can write them like this. That the cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Cool? Cool beans. All right? So now, let's use this right triangle to figure out these trig ratios. Now, we totally do not care what theta is at this stage of the game, you guys. All we want to do is get those fractions. Good? Lucky for us, they labeled all the sides of the right triangle, and we're good. We're good to go. 13 is the hypotenuse, right? And here's theta, so to get in my car, I got to drive to this side, so this is opposite theta. And then 12 is right next door, so it's adjacent. So now that I identify where the opposite side is and the adjacent side is and where the hypotenuse is, I can bam, 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 just do these ratios. The sine is opposite over hypotenuse. So that would be 5/13. Immediately I can get the cosecant because the sine and the cosecant are reciprocal. So 13 over 5. Blam. Okay, now let's do the cosine of theta. That's adjacent over hypotenuse, right, you guys? So that's going to be 12 over 13. And blam, do I get the secant? Yeah, I do. It's 13 over 12. Now, tangent, you guys. Tangent, we'll do that one in black, is opposite over adjacent, isn't it? So opposite is 5, adjacent is 12, and blam, I get the cotangent, which is 12 over 5. So now I've identified the first 6 trigonometric values of theta. Let's slide here. Ooh, this is so cool because we're mixing it up. We're mixing it up. So the hypotenuse is the hypotenuse of the right triangle. You're like, what is it? Yeah, it's the hypotenuse. And 5 inches is the hypotenuse. Okay, first of all, I need to get the third side. And of course, our friend Pythagoras can help us. The Pythagorean theorem says that a squared plus b squared is equal to c squared. And c is always the hypotenuse. A and b, A is 3. And B is we don't know. Okay? Now you're like, well, how come A is 3 and B can't be 3? It can. You can reverse them. It's fine. But I'm just saying that I'm using A because it's kind of opposite the side that has the Greek letter alpha. So this will be 9 plus B squared is equal to 25. B squared is equal to 16. B is the square root of 16, which is 4. So I'm psyched. 4 inches. Perfecto. Now, you're going to be like, what? What's going on here? First, we're going to do alpha. All right, let's work on all the alpha stuff first, and then we'll work on the beta stuff. Okie dokie artichoke. So the sign of alpha is opposite over hypotenuse. The opposite to alpha would be 3 inches, and the hypotenuse is 5. Okay? Now, yay. Okay, so we got that. Now, what about the tangent of alpha? Well, the tangent is opposite over adjacent. So that would be 3 over 4. Looking good? So far, so good? Now, what about this secant? Well, secant is hypotenuse over adjacent, just knowing that because, we just know it. So it's 5 over 4. So we're doing great. But now here's the beta piece, you guys, and I'm going to do this in red. I'm going to do the beta piece in red because opposite beta, here's my opposite for beta. That's for beta. And my adjacent for beta is 3. And the hypotenuse is the hypotenuse is the hypotenuse. So the cosine of beta will be adjacent over hypotenuse, which is 3 over 5. Cool? The cosecant of beta, well, cosecant is hypotenuse over opposite. So that would be 5 over 4 for beta, you guys, for beta. Now, cotangent is adjacent over opposite, but adjacent is 3 over 4. So what do you know? What do you see about the red and the blue in this case? They're the same. So now we're going to talk about cofunctions, okay, in a second. And what can you tell me about alpha plus beta? Well, alpha plus beta, angle-wise, is going to equal 90 degrees. And you're like, why? Well, the sum of the angles of a triangle is 180, but I've already got one 90-degree angle, so the other two must add up to 90 degrees. Cool? So the sine of one of these angles is going to equal the cosine of the other. They're cofunctions, and you'll see this a little bit more as we go. Let's do the next slide. Okay, so what we're going to do is talk about cofunctions. Good? So here's the deal. Now this is a little confusing. We're going to do the cofunction piece first, and then we're going to do the reciprocally thingy-wingy. All right, so the sine of 35 degrees is the same as the cosine of 55. Now 35 plus 55 is 90 degrees. So if I drew my right triangle, this would be 55 and this would be 35. So it would be like the alpha beta scenario. Cool? Now, I want to go back to something over 35 degrees. That employs the reciprocal. And the reciprocal of sine is cosecant. So this little guy is going to be cosecant. Now, this is hard to get initially, but your instructor can help you, wade through some of this. Now, again, the cotangent and the tangent are co-functions. Cool? So I need to get that other angle. Well, what is that other angle? Well, I need to figure it out. To me, I'm thinking it's 78. Now, you might be saying, well, why 78? Because 78 and 12 give me 90 degrees, and that would be like my little, I'll do like a skinny. So this would be my 12 degree thing, and this would be my 78, and there would be my right angle. And then you're going to say, well, what is the flip of the cotangent? Well, the flip of the cotangent is just the tangent. So the beauty of it is that they're both co-functions and reciprocal functions at the same time. It's really interesting. The angle stays the same when you do the reciprocal thingy-wingy, okay? Good? All right. Want to do another one? Yeah, let's. Well, secant, the co-function for secant is the cosecant. So here we go. So notice how these guys add up to 90 degrees, and then we get our cofunctions. Ready? Let's do cofunctions. The cofunction of the sine of alpha will equal the cosine of beta. And this is provided what? Alpha plus beta equals how many degrees? How many? 90 degrees. The tangent of alpha will equal the cotangent of beta, provided alpha plus beta is equal to 90 degrees. And then the secant of alpha will equal the cosecant of beta, provided alpha plus beta is equal to 90 degrees. Is this exciting? And then the reciprocals, so these are the co-functions. I'm just trying to kind of get it so that you have this. I would totally write this down. Okay, and then the reciprocals, the secant of alpha is equal to 1 over the cosine of alpha. The cosecant of alpha is equal to 1 over the sine of alpha. And the cotangent of alpha is equal to 1 over the tangent of alpha. So when we're doing recip, the angles stay the same. When we're doing cofunctions, the angles will add up to 90 degrees. Yay! Okay, next. Now, let's do this one. This doesn't have any triangle associated with it, but we're going to draw one. So here we go. First, we see that the cosine of theta is 8/17. So we write 8/17. And blam, we can get the secant because they're just reciprocals, 17 over 8. Now the rest of them, I'm going to draw the triangle and label theta. I like labeling it in the lower. Here's my right triangle. 17, what is cosine? Cosine of theta, that's adjacent over hypot. So the adjacent side's going to be 8. The hypot is going to be 17. So we just have to figure out this side. Okay? And what do I use? Well, Pythagoras to the rescue. 8 squared plus b squared is equal to 17 squared. So 64 plus b squared equals 289. So I'm going to subtract 64. So b squared is equal to 225. B is going to equal the square root of 225, which is nice. It's 15. So blam, we can get the rest. Sine is opposite, which is 15, over hypotenuse, which is 17. Blammo, I can get cosecant by do 17 over 15. Tangent is opposite over adjacent. So in this case, that's my opposite is 15. My adjacent is 8. Blammo, I can get cotangent just by flipping it around. Perfect. Now let's do the next. Same idea. Here we're given the cotangent is 2 over 3. So I just fill it in. Perfect. Blammo, I can get the tangent. I know you're sick of me saying blammo. I'm sorry, but I can't help myself. All right. So let's label this theta. And this guy will be opposite. This guy's adjacent. And I need my hypotenuse. So the opposite, I'm going to use tangent because that's opposite over adjacent because I can remember that one better. So it's 3 over 2. And now I'm going to solve for the hypotenuse, and I'll be able to get all the rest. So 3 squared plus 2 squared is equal to c squared. 9 plus 4 is equal to c squared. 13 is equal to c squared. So c is the square root of 13. And just leave it like that. Okie dokie. Now, let's get the sine. Sine is opposite over hypotenuse. So it's 3 over square root of 13. Blammo, I can get cosecant, which is square root of 13 over 3. Now let's do cosine, which is adjacent over hypotenuse. So 2 over the square root of 13. Getting the secant, it's square root of 13 over 2. There's only one glitch on this, is that I need to get the radicals out of the denominator, so I'm going to rationalize the denominator by just multiplying by the square root of 13 over the square root of 13. So this will be 3 square root of 13 over 13. The cosine, I'm going to do the same thing. So this is 2 square root of 13 over regular 13. Because when I have the square root of 13 times the square root of 13, I'll get the square root of 13 times 13. Pair comes out as a single. You're all set. Sometimes when you do your homework in this, they'll want you to rationalize the denominator. In other words, get all those radicals out of the basement. Okay, now you're going to be able to do the homework associated with this section. Good luck and have a great time. Stay the course, do the math. You can do it.